Okay, so in this example, we're supposed to factor out the monomial. So when we factor out the monomial, we want to start by asking ourselves three basic questions. The first question is, what is the largest number that goes into both terms? The answer to that question here is 2. 2 is the biggest number that goes into both 4 and 6. Second thing I want to ask myself is, do I have a variable in each of my terms? And I do have x in both terms, so I can pull out x as well. And we can only pull out the lowest exponent we see. The second term is implied to have x to the first because there is no exponent, so we can only pull out an x to the first. And finally, the last thing I want to ask myself is the leading coefficient negative? Or is the term with the highest power negative? If you look, the x squared is our highest power. It has a negative coefficient, which means I actually want to pull out a negative 2x. So to factor out the monomial, I first started by finding the greatest common factor, which is negative 2x, which really isn't the greatest common, but it is the common factor we need to use. Now that I know that, I'm going to divide both terms by negative 2x, so I can find the other factor. Negative 6 divided by negative 2 is positive 3. X squared divided by x leaves us with 1 remaining x. In the second term, we have 4 divided by negative 2, which is negative 2. And x's in this case will cancel out, leaving us with negative 2x times, in parentheses, 3x minus 2. So in this example, we're going to factor the expression x squared plus 7x plus 12. Going through the process, we would check for monomials. There is no number that goes into all three terms. Second thing we would look for is if it's a pattern, but it's not a pattern because, well, it doesn't match any of the patterns, whether it's a perfect square minus a perfect square or the a squared plus minus 2ab plus b squared. Doesn't match either of those patterns, so it's not a pattern. So we're going to go ahead and multiply first and last. Get 12x squared. We need to find factors of 12 that add up to be the middle term, which is 7. So I'm just going to list the ways we can factor 12. 1 and 12, 2 and 6, 3 and 4. So we are looking for, it looks like 3 and 4. Now because there is no 1, we don't have to do the other steps that we have in our chart because the leading coefficient is 1. So the factors are just going to be x plus 3 and x plus 4. Done. Okay, in this example, we're factoring the expression 2x squared minus 5x and minus 3. So we're again going to be using grouping and just going through the process. The first thing you want to check is to see if there's a common monomial that goes into all three terms. And there is nothing that actually divides all three terms for this example either. The next thing we want to check is if it's a pattern, and we're going to take a look at patterns in one of the later videos. This one is not a pattern. Most of the patterns have 2 terms, and this has 3. It also requires perfect squares or perfect cubes on the first and last terms, which this does not have. So next thing we're going to do is we're going to go through the guess and check process with factoring by grouping. So we're going to multiply the first and last here. Get negative 6x squared. Then we're going to list the ways we can factor 6. And you don't have to list the ways. Sometimes you can figure it out without listing them. But if you have trouble, listing the ways is a great way to go. So 1 and 6 and 2 and 3 are the different combinations we can use. Now I know since they multiplied to be this number, and add to be this number. Well, because they multiply to be a negative, one of them has to be negative. So I'm just going to make this negative and just double check. Do either of the combinations I now have add up to be -5? Well, no, but -1 and +6 adds up to be +5. If I just change which one has the sign, we should have it. +1 and -6 add up to be -5. And +1 times -6 multiplies to be -6x squared. So this is the combination I want, and just like before, we're going to add an x to each of them, since they have to add up to be 5x and 6x squared. Now, with that in mind, we're going to go on to the next step, which is rewriting the expression. We're going to replace the -5x with the two factors we found, the 1x and the -6x. Of course, the -3 will come down as well. Now that we've rewritten the expression, we're going to go ahead and do the grouping. So the first two terms are going to be grouped together, and then the last two terms will be grouped together as well. To pull the monomial out of the first two terms, well, what goes into both? Number-wise, nothing goes into both 2 and 1, so we could put 1 as a placeholder, but it looks like we'll also have an x, which it looks like I forgot my squared there. Since x goes into both, I'm not going to actually keep the 1, because 1x and x are the same thing. So we're going to just pull an x out of both terms, and the higher power here has a positive coefficient, so we don't need to pull out a negative. So we'll divide both terms by x now. Give me just 2x plus 1x divided by x is 1. In the second two terms, in that second grouping, what goes into both -6 and -3? Well, the biggest number is 3. No x's in both terms, and since the higher power has a negative coefficient, we're going to pull out -3 instead. We'll divide both terms by -3. So that's going to give me a positive 2x and a positive 1. Remember, when you do factoring by grouping, this result should be the same when you get to the binomial parts. In that final step, since we do have the same binomial in both terms, we can pull that out, or both groupings, not both terms, but we can pull that out, and that leaves us within the first grouping an x left over, and in the second grouping a -3 left over. So here are the factors. Okay, in this example, we're going to factor the expression 4x squared minus 25. Now, when we go through the factoring process, the first thing we want to check to see is there a common monomial in any of the terms we're starting with? And no number goes into both 4 and 25. There's not a variable in both terms, and the highest powered term is not negative. So there is no monomial that we were going to want to pull out. The second thing I want to check is it a pattern? And now, we haven't actually had an example yet where it's a pattern, but this one is indeed a pattern. And the patterns that you can look at are a squared minus b squared pattern. There's also a pattern where it's a squared minus or plus 2ab plus b squared, and a squared minus 2ab plus b squared. These two are just condensed on the formula sheet and written as plus or minus. So a squared plus or minus 2ab plus b squared. Now this one is a little bit harder to recognize. So at the very least though, know how to use the a squared minus b squared, which is actually what this particular example is going to look at. The other one is definitely harder to recognize. So for this one here, I know it's a pattern. I know it's the a squared minus b squared pattern, because if you look at it, both terms here are perfect squares. 4 is a perfect square. We square 2 to get 4, and so is x squared. They're both perfect squares. And in the second term, 25 is a perfect square. 25 is 5 squared. So you can see that it matches, if I rewrite it like this, it matches the a squared minus b squared kind of notion. Now, according to the factor chart that we have with the formulas on it, the special pattern here, a squared minus b squared, factors into a plus b and a minus b. The a and b are what you square to get the original polynomial. In this case, a is going to be the 2x that's in the parentheses, and b is the 5, which means our factors of 4x squared minus 25 is 2x plus 5 and 2x minus 5. And that's it. I'll also say you can do this with the normal factoring by grouping. Just got to remember that you would rewrite it as 4x squared plus 0x minus 25 if you're going to do, if you're going to try to do it with factoring by grouping. So.